Hi everyone, today we're going to be going through transformations to circular function graphs, your dilation, reflection and translation, what they mean and how they're going to affect the overall look of your graph. Now, when it comes to circular functions, it's really easy to see the shape and how transformations change these shapes. And there's three different transformations that we go through. And whenever we go and figure out what these transformations are, we follow this order. And the first is dilation. So we figure out how much a certain graph has been stretched or squished. After that, we look at our reflections, and then we look at our translation. Now, unless it's been otherwise specified, this is always the order to do it in. Okay, so dilation, reflection, translation. Now, when we do dilate, this is where most people do get confused. Is that if we have a number out the front of the x, that dilates it by a factor of 1 over that number. So for example, I had 2x, it would be dilated by a factor of half from the y-axis, okay? Whereas when we dilate with a number out the front of the whole function, it's just from a factor of that number. And the reason is due to the mapping, which we're going to have a quick look at as well. So if we had a look at this function here, we're mapping from cos of x and we're going to 3 times cos of x plus 4, okay? When we map, we like to use something called y prime and x prime. So our original function here is y equals cos of x, and I'm going to call our new function y prime, and we're going to replace x with x prime. And the reason we do this is just so we don't get confused between our original function and our new function, okay? From here, we need to rearrange our y prime. So doing that, I'm going to have y prime take 4, because we would subtract 4. And then I would be dividing that by 3, because we had the 3 out the front. And then the x prime is just going to stay the same on the inside, okay? This means that when we're mapping, our y is going to be equal to our y prime take 4 over 3, and our x is going to be equal to our x prime. Now we need to solve once again for y prime, because we're trying to figure out how we've gone from y to y prime. And so that's why, once we rearrange, that when we are dilating with a factor in front of the function, that because we end up rearranging twice, we end up just having the number out the front again. So this function here dilates from a factor of 3 from the x-axis, and then it's going to translate 4 units in the positive y direction. And all that means is it's going to translate 4 units up the graph. Okay, so 4 units in the positive y direction. So when we graph this one, and we've already seen this with things like amplitude and period and our maximum minimum values, but when we graph this, that means our original points of our cos graph are going to be shifted a bit. So I'm going to start by just drawing our usual cos graph here, just so we can see exactly how our function's changing. Okay, I'm just going to do this from 2 pi to 1, and over here we've got 0, 1, and then pi, negative 1, okay? When we're finding the transformations from one graph to another, we're doing it for every possible coordinate. Okay, so we do this generally so that I can then pick coordinates to move around. All right, if I, for example, take 0, 1, and I now dilate that a factor of 3 from the x-axis, that means I'd multiply it by 3, and so we'd end up here. But then I'm also going to translate this 4 units up. So now instead of having 0, 1, we're going to have 0, 7, okay? So 0, 7 for that one. Same thing for pi, negative 1. If I dilate that a factor of 3, I would end up at negative 3, and then I'm going to move 4 units up. So we actually end up at positive 1, okay? Because I'd be at negative 3, and I'm going to move 4 units up. That means my new coordinate is going to be pi 3. And then same thing, 2 pi 1. Our y coordinate is going to have the same thing done to it. We'd end up at 2 pi 7. Apologies for my scale being a bit out of whack, but I hope that it makes sense with the transformations that we've got. And we can see that the period hasn't changed, but the graph has been shifted up due to the dilation and the translation, okay? Feel free to have a go at this one by yourself, but I'm going to go through it again using the same sort of method. So I have y is equal to sine x, which means that my y prime is going to be equal to negative 2 sine 2x prime minus 1. And then we do our usual rearranging again. So I've got y dash plus, not plus 2, sorry, plus 1 divided by negative 2 is equal to sine of 2x prime. Now that I've got that, I've got y is equal to y dash plus 1 over negative 2, which means that y dash is going to be equal to negative 2y take 1. Whereas here I've got 2x dash is equal to x, so x dash is equal to half x. So that's why when I dilate by a factor in front of the x, that it becomes a fraction rather than the number itself. So here I've got a dilation of factor 2. Oh, sorry, factor half. I don't know where this 2 came from. Apologies. But I've got factor half from the y-axis, which means that it's going to shrink towards the y-axis, which will change our period. And then I've got a reflection in the x-axis and a translation 1 unit down, so 1 unit in the negative y. All right, now feel free to draw your original sine graph if that's going to help you visualize what's happened here. But I know on my original sine graph that I have a point here that is 0, 1. So I'm going to follow these steps. If I dilate a factor of half from the y-axis, that's not going to do anything because our x value is 0. If I reflect it in the x-axis, that's going to move me down here to negative 1. And then I'm going further down 1. So I'm going to start this graph here. Should be at negative 1. Oh my goodness. Starting at 0, reflect doesn't do anything and moves me down 1. Once again, apologies for that. Now we're going to do the same thing for the other points that we know of. So at pi on 2, we know that our sine graph is usually at 1. I'm going to dilate this a factor of a half, so I'm going to move it down. Oh, sorry, I'm going to move it to the left and shrink that by a half. And then I'm going to reflect it and translate it 1 unit down. So that means at pi on 4, because I've shrunk that value down by a half, at pi on 4, I'm going to be at negative 2. Okay? If you keep repeating this process, you should end up with pi on 2 gets you to negative 1. 3 pi on 4 would get you to 0. And then pi would get you back down to negative 1. And then hopefully what you'll see here is that will do 1 cycle for you in pi instead of 2 pi. So our period has also been shrunk by 2. Okay? If I was to draw the original sine graph, it would look a little something like this. Oh my goodness. And it would end all the way over here at 2 pi 0. So we've shrunk that by a half and we've just moved it down the 1.